morning, everybody, and welcome to the latest installment of JavaScript Live. So this is part of the live series that we host here at Amicus Recruitment. So my name's Christy O'Brien. If you've not already heard of me, I recruit for front-end JavaScript roles for companies within London and also remote positions. So today we're joined by JavaScript expert Yann Buydens, who will be giving us a fantastic talk around testable documentation. So as always, the sessions today are designed to be very interactive. So if you have any questions at all for Yann, please use the Q&A section below. And we'll make sure that your questions are answered. But anyway, that's enough from myself. Yann, thanks for joining us, and please feel free to start whenever you're ready.
Yeah, thanks, Christy. Hi, everyone. Glad I can give this talk about testable documentation. I think it's kind of a pet peeve of mine. I'll start sharing my screen. There we go. Let me know when you can see it. I think you can.
Yeah, I think we're ready.
Perfect. So I'll quickly hide myself. Okay, so who am I? Well, previously I was the technical co-founder of AWell Health. So AWell Health allows you to build clinical workflows, and it's an amazing product, and I really highly recommend you to check it out if you're looking for a tool that can help you with clinical workflows. And yeah, AWell was built completely on the JavaScript stack, Node.js in the backend with TypeScript and React in the front end. But yeah, currently I'm building a code documentation tool, so maybe not a surprise here given the name of the talk, the topic of the talk. And I'm also actually doing freelance work, so helping companies with software development, really at any stage of the project. So briefly an outline of the talk. So first I'll give you my kind of idiosyncratic definition maybe of what software documentation is. Then secondly, I'll explain why it's important. And three, why I think there isn't enough software documentation, followed by part of the solution that I think we can provide. And then I'll just give you a taste of what I mean when I'm talking about derivable and testable documentation as part of the solution by illustrating it with 5 tools that I know and kind of proof of concepts that I've built. So yeah, so that's sorry, I did closed my my full screen here. Anyway, so yeah, so that's the plan. So let's jump into it. So first of all, what is software documentation? So to me, it's very broad, right? It's basically anything that can help you understand the behavior and conventions of your software system, right? And if you take that definition, I think actually the best kind of documentation is the code, right? It's the untyped code, because that's kind of the authoritative source of truth of how your software is going to behave, right? It's the actual code that the instructions that the computer is going to execute. Then a second type of documentation you typically find is the type system, right? So in JavaScript land, that's TypeScript flow, and that's great documentation because you can test for it, and it tells you kind of the signature of a function, etc. So definitely something that helps you understand your software. Then the third type of documentation, which is also great documentation, is tests, right? Unit tests, integration tests. In JavaScript land, Jest, Cypress. I mean, it's a way to describe the intent of your software without writing the implementation, right? And you run the test, that documentation is always up to date. Then moving on, the localized documentation. So what do I mean by localized documentation? Well, it's typically kind of what you add above functions, methods, and classes. The JS docs that tell you a bit more about a given function or method or anything really. And it's localized because it's close to the thing that it's documenting, right? Hence the name localized documentation. Then the other sort of documentation is non-localized documentation, and that's typically what you find in READMEs, which highlight kind of broader concerns in your code base, how you do error handling, for example, your architecture of your system, etc. It gives you kind of a bigger picture of the code base. And then finally, I also think that static analysis tools fits into my definition of software documentation, because it helps you document the conventions that you should follow in your code base, right? And it's great because, again, you can test for it, right? You can run it, and with Prettier it can even like do the work for you. So it's amazing. Those are amazing tools. And I think kind of if we take stock, as an industry in the JavaScript community, I think we've adopted a lot of the documentation that I listed here, which is great. But I think we don't invest enough in localized documentation and non-localized documentation, and I think it can bring tremendous value over the long term when done right. So why is it important? Why is kind of this localized and non-localized documentation important? Well, I'm giving here 4 reasons, but there are probably more. But for me, the one reason is that it helps you highlight important non-obvious details of your codes. Sometimes you have to implement a very complicated algorithm, right? It's inherently complex, and even if you write the best kind of code, it's still complex, right? And so adding those extra details about how the algorithm works, I think, is very valuable, right? And that can only be done through non-localized documentation, in my opinion. Another kind of benefit of some type of non-localized documentation is it can give you a broader view of the code base, a bigger picture, right? So an example of that is the dependency graph. And I'll show you an example later on in my talk. Another reason is that you often have things that are spread throughout your code base that you actually should kind of state explicitly, right? For example, how error handling is done, right, throughout your code base. I think it's good to kind of have a place where you express that explicitly, right, for people, instead of people having to figure it out by looking at the implementation and reading the code. It's like, if you're in biology, you're only allowed to read the DNA, and you're not allowed to look at kind of the animals, right, to understand their behavior. Like you could do it, but like, yeah, why? It's a lot of wasted time there. And also, I think it's a vital tool for us to create great abstractions, right? And that developers can use without needing to read the implementation of classes or functions or modules. I think kind of as developers, we spend way too much time reading the implementations when we should actually just be reading, the READMEs and going from there. But yeah, unfortunately, that's not the case right now, right? We often read too much implementation and not enough. We can't rely on just the kind of abstractions that we then build on top of. Okay, so I think I've convinced you that documentation in all its forms is important. So why isn't there enough software documentation? And I think I identified three reasons. One reason is good. The other two, I think we can do something about it, and we should do something about it. So the first reason why there isn't enough documentation is no time. You have the pressure to deliver the next feature. And actually, I think that's a very good reason, right? So if you're a startup and coming from that world, I understand this. If you're not sure you're going to be around in the next 12 months, you shouldn't be concerned about the long-term maintainability of your code base, right? So first make sure that you're still alive in 12 months, and then come back and write and spend a lot of time on documentation. The second reason is that it's too much effort, right? These READMEs, And these comments, you need to write the code twice essentially, once in code and then one is in this localized, in this documentation. I think that's where I want to focus the rest of the talk on, how we can alleviate this and make it less effort to create it. And then thirdly, I think I can't do it, right? I think the main reason also, one of the main reasons is that, writing, prose is just hard. And, but that's not the topic of this talk, but I think investing time to write well, I think is super valuable as a developer. Right. So on this second part, the effort, I think the part of the solution lies in investing in derivable and testable documentation. So what do I mean by derivable documentation? Well, it's documentation that derives from your code base, right? So it's downstream from your code base. And examples from that is your UI, right? I think a lot of people use their UI to understand their code, right? And it's a way to document the code, right? And it's a great form of documentation. Another is Dependency Cruiser. It's a library that I'm going to showcase you guys later in the talk. And then another example is Domain Dictionary, which is actually the tool that I'm working on, that I'll also tell you more about later. So that's derivable documentation. You configure it, and then it's always in sync with your code base, right? Then the second, and that's really kind of, the lowest effort type of documentation, derivable documentation. So I think kind of it's worth setting up, because it's only the setup cost, and then you have it for life. Okay, so that's derivable documentation and testable documentation. What do I mean by testable documentation? Well, if you can run automated tests on your documentation to make sure it's in sync with your code base, then that's testable documentation, right? And so kind of the usual testable documentation that we know and love is unit tests and integration tests, but there's more, right? And so there's doc tests, there's code generators, there's directory lint, there's README assistant. You probably haven't heard of those last four, but I'll tell you more about those. Okay, so that's for the theory. I want to do some demos. So now kind of I'm going to go through those examples that I illustrated and show you how it works. So for example, the first example here is Dependency Cruiser, right? And what does it? Well, it helps you validate and visualize your dependencies. So let me jump into my editor. Okay, so what we have here is, don't mind the other directories for now. We have a basic node application with a source directory, and in there you have an index file that imports a file in your directory, dir a directory, and this module A file imports from libutil file, right? Great. And so you can definitely kind of go through that and see this by reading the code, but you could also run one command, this one here, and then see the results at a glance, right? And so this is kind of much easier, obviously, to see how the dependencies work, and kind of when you have a bigger code base, obviously, like it's way more valuable, but it's just much faster to see how kind of the dependencies run in your code base. And what's really cool with Dependency Cruiser, and I'm not going to showcase this, but you can actually kind of also configure rules, right? For example, if you want the util file to be only imported for some reason by the files in the directory dir a, you can configure that, right? So it's also a way to kind of enforce certain rules in your code base. So that's one example of derivable documentation. Okay, moving on to the next one, the domain dictionary. So that's actually a tool I'm currently building, and the problem that I that I saw and that I experienced at AWOL, but also is shared among many companies, is that what you have is a code base, and then you have an internal wiki that has all the definitions of the terms that are important to the business, right? And that should be kind of known to everybody in the team, right? So making sure that everybody speaks a common language, that there's no kind of translation work between the product team and the business, or the product manager and then the developers. And so what I see 99% of the time is when the size gets big enough, this internal glossary of terms gets created, and a lot of effort is put into it initially. But then, it gets out of sync, and then people don't rely on it anymore, and then the effort gets lost and disappears. And when I ask people about this, it really isn't because it doesn't provide value, because they all say like, oh, we should definitely do this. But it's just because it's a lot of work, right, to keep these things in sync. So what I build is a tool that scans your code base, and then make sure that the glossary of terms kind of is in sync with that. So I'll briefly show you what it looks like. So here you have your domain dictionary of this application, right? And you have all the concepts that are being used in the code base. So I scan through the code base and kind of create tokens. And yeah, there are concepts about your tech stack, but also about your business, right? And in my business, I'm in the business of kind of code and repos and declarations and pull requests. And I can here give kind of this canonical definition that people can of every part of the business can look at. And for example, yeah, you have PR here, which is the shorthand of pull request, and you can see in the code where it's being used across actually different code bases. And what's really cool about the tool is that it keeps it in sync, because every time there's a new pull request, it scans your code and checks whether there are new concepts being added and flags those, right? So that's kind of an example of derivable documentation, right? Because this glossary of terms is downstream from your code base, right? New items get added when they get added in your code base. Okay, so moving on. That's example 2 of derivable documentation. Next example, doc tests. So what are doc tests? So those are executable usage examples. So yeah, the doc tests finds and evaluates usage examples in your code, comments and reports any accuracies, right? And this is actually something that's common in a lot of languages. Like I know that Python has it by default, where you can write doc tests. JavaScript, unfortunately, doesn't have it, but we have a very rich ecosystem. So there are a lot of packages that allow you to do this. So let me show you an example here of how to use this. So you have your function implementation. You have its signature. 2 Fahrenheit takes a number, returns a number. Human readable kind of short description of what it does, and then some examples, right? This is super clear documentation. But how do you keep this part in sync, right? Because I think kind of nobody wants to keep documentation in sync with the code manually. We should at least be it should at least be flagged when it changes, right? So doc test, and you can look at it on npm, allows you to do this. So I just run, let me just run up. So npm doc test example. There are no errors here, so pass is fine. Let me change this 2 to a 3. Run this again. Fails, right? Tells you expected yeah, 213 on line 8 and got 212, right? So that's another kind of example of testable documentation. So DocTest works with JavaScript and CoffeeScript. I'm actually working on a version that works on, with Babel and Webpack, but it's not ready for prime time yet. But if you're interested to work with me on this, definitely reach out. There are a lot of packages. I didn't look at all of them, so maybe because this is a project I started a few years ago, actually. In the meantime, there is a package that does exactly what DocTest here does, but for the modern JavaScript stack that works with Babel and Webpack. So yeah, actually, let me know if you use a package like that, so I can use it as well. I need to rebuild it. So that was DocTests, what DocTests are, and an example of testable documentation. Then of testable documentation are code generators, right? So people know of Yeoman, which is a package that an NPM package that allows you to generate documentation. I'm not a big fan of it. I think it's way too complicated. But there are other kind of super lightweight code generators that really are simple enough that it can count as documentation. So let me show you an example of that. So we have an app here, a very basic Express app that has an app directory and a routes file that exposes a posts endpoint and a user's endpoint, and then actually don't mind the this. It's not actually working, and then kind of has the implementations of those endpoint handlers in a handlers directory. Each endpoint has its own file, posts with an index file that is the entry point of this directory, and then you have the actual implementation in the file that's named after the parent directory, right? Posts, and then you have your tests post.test, and that's kind of in this code base how you should create new handlers, and this is kind of the convention that you should follow. You should have an index file. You should have a file that takes the name of the parent directory and that holds the implementation, and then you have a test file, right? So that's the convention. And so typically, how you enforce it is through code reviews and by having people look at the code and doing that. And I think that's kind of a shame, because there are tools that allow you to win a lot of time. And one is Hygen, which is a very featureful code generator. But so their concept is, instead of having your code generator live in another code base, it lives next to your code, right? In this underscore templates directory. And there you define, that you have a route generator and different kind of actions. Here you have a route new, and here it holds all the templates. But here already this is documenting obviously how you should create new handlers. And what's really nice about this is it's also testable, because you have developers using it, and if it gets out of sync somehow with the latest conventions, it gets picked up very quickly, right? So I don't want to go too much into the details of how it works. There's a small learning curve, right? But it's really 15 minutes and you understand it. But what you can then do, right, and that's something I want to show you guys, is to then just create new endpoints, right? So let's say we're interested in blog posts, right, in having an endpoint blogs, right? We just run this, and what happens a new file got created in a directory called blogs, an index file, blogs.test, and actually the existing files have also been changed, right? So let's have a look. Sorry, not in this directory, in app handlers. So now you have a directory called blogs with the variables kind of exchanged here. And then also in the routes file, you have this import that's added automatically. And okay, so there should actually have been a line here, and I think I know why, but that doesn't matter. You get the point. It automatically also injects lines of code in existing files, right? So it can save you a lot of time, and it's way more flexible and user friendly to change than kind of the other code generators that I've seen out there. These are kind of human-centered, I would say, code generators. So before Hygiene, I actually wrote another package for myself called YoDude, kind of a play on Yeoman because I wasn't really satisfied with it. But yeah, the concept is very simple. It lives at the root of your directory, of your code base, and you define, for each directory in YoDude's templates, you have a generator, right? So you have a component generator with instructions. So I think it's very simple how to configure this, and a place where you need to copy it to. And then kind of you name here the variables that you need to kind of substitute once you generate, when you use the generator. So component name needs to be kind of filled in when you call the generator, and then you use it throughout your directory here. So component name here, the directory name is component name, but also kind of the file names, and inside the files you also have component name everywhere. And once you've done that, you can actually do YoDude. Then you see, which template would you like to use? There's only one template right now, so I'll use the component template, and then I'll call it modal. I want to create a new modal component, right? And by doing this, now I have a modal directory with the different files that I specified here. And so you get documentation, right? Because it lives in your code base, and you get automation as well, right? And as a third kind of bonus, now you have testable documentation, because if developers rely on it, you'll know when it's broke. Right, so that's code generators. Fifth type of testable documentation, or fifth example, sorry, it's called directory lint. It's a play on ESLint. This is also a proof of concept. They say that an open source project, when it has a logo, it's real. So I went on DALI 2, OpenAI, and asked an image of a snobby English professor looking at the retro computer screen wearing construction gear, and that's kind of what it gave me. Let's jump in on the example here. So what directory lint does, I didn't really explain this. It's a way for you to check your directory structure against a defined structure, right? Against the configuration. And so kind of the configuration here is here, right? It's under the dir rules.yaml, and you express kind of how you want your directory structure to be. I think it's a very kind of human readable way. So here, typically the rule is that we should have an index file at the root, and then basically any directory in the code base should be Pascal case, and then inside of it you should always find an index file, a name of the parent directory, sorry, a file that has the name of the parent directory, a TypeScript file, and then you should also have a story.ts file that has also the name of the parent directory. Yeah, in those files. So if we look at the code base here, this satisfies the rules, right? So you have an index file, which is great. Well, there are rules that is like that's always valid, right? So don't look at that. But then you have also a directory called hello, which is Pascal case, and inside that you have the 3 files that you specified you want in there, right? And so if you do yeah, dir lint dot source. Sorry, I'm in the wrong directory. It tells you that it's valid. Now, if you add something, if you change, for example, hello into camel case, right? Not Pascal case anymore, it's going to complain. Invalid directory structure, right? It's a proof of concept because kind of the output is not very human readable, but you can definitely see if you want that there is an issue, right? And I can read this, but there's some work I need to do to make this more human readable. So again, an example of testable documentation. And if you add another file here, .js, it will also complain, right? Because it has this item foo.js that it doesn't know about in your specification here in directory rules.yaml. Dir rules.yaml is always allowed to be in any directory. So you don't need to specify this here. Right, so that's example 5. Moving on to my next example. This is also a proof of concept of mine. I think more of a toy example, but I think I wanted to show it because I think there are more possible ways to have testable documentation. It's called README Assistant. What you also typically see is in READMEs kind of a README that tells you it's definitely at the root of a code base, what the different directories do, lists them, what they're all about, and then kind of the files as well. I've seen this in a few places, but this is also something you could definitely keep, have a tool, ensure that it's in sync with your actual code base, right? So that's why I created this thing called README Assistant. So let me show you. So you call README Assistant validate. And tells you, okay, you're missing this file demo.sh in your readme.generate.md. So there's this .g.md, which tells you that it's the generated README. You could configure it to be called, readme.md, but I wanted to make a distinction. So I need to add a new file entry here called demo.sh because it doesn't know about it. So I have here demo.sh holds. I have GitHub Autopilot on, holds the command for the demo, right? Okay, so I've added this here. Now I can run it again. And no issues, good to go, right? So that's the last example, README Assistant. and helps you keep your readmes up to date. Yeah, so we're getting to the end of the presentation. So yeah, reach out if you want to collaborate on any of these ideas, because I'm at the beginning of all of them. If you want help integrating these documentation tools in your company, reach out. Or if you need help with, any ongoing or new software projects, don't hesitate to reach out. Here's my email. And that's all, folks. Thanks for dropping in, and happy to answer some questions.
Brilliant. Well, yeah, on behalf of everyone else, Yann, thank you for doing this. Just having a quick look to see if there are any questions, but yeah, as I can see, I don't think there are any. So yeah, just going off what you said before, if anybody's got any questions after this, please feel free to reach out to Yann. It's been brilliant having you on the live series. I really appreciate, you taking the time to do this talk for us. So yeah, if anybody would like to rewatch this or pass it on to any of your friends, I will leave a link to the YouTube video on my LinkedIn post tomorrow. But also be sure to follow the live series account on LinkedIn to keep up to date with all of our upcoming events, which are webinars, podcasts, and also roundtable events as well. And if anybody is looking to do a presentation like this in the future, then I'm happy to talk about topics that you'd like to discuss, as Yann has done today for us. So Yann, if you've not got anything else to say, then yeah, I think we can stop the webinar there.
No, I've said everything I had to say.
Brilliant. Okay.
Thanks for hosting it.
Thank you, Yann, and thanks to everybody that was watching it. But yeah, everybody have a great night, and tune in for the next one.
Bye, everyone.